On the second day, God creates the slidey chair. Entertainment ensues. Today, we will be using slidey chairs for the purpose of physics. We hope you enjoy.
Okay, alright. So because this is a closed system, the momentum can be conserved when Trevor collides into Raul. So we can say that the momentum is equal to mv. So here we have P1 equals P2. So this is Trevor's momentum equals my momentum. And we can write this as m1 v1 equals m2 v2. And these should be equal. And we know that both of our masses are 72.5 kilograms. And the initial velocity of Trevor is 1.38 meters per second. So then we can solve this to find what the expected final velocity should be. So let me just do that real quick. Alright, this is it's canceled out. So then V2 equals 1.38. So we would expect that the final velocity of my chair would be 1.38 meters per second under ideal conditions, but we actually tested it, and by looking at the frames in the video, we found my actual final velocity to equal 1.28 meters per second. So this is not completely perfect, but due to testing errors, it's off by a little, but it's close enough to prove the point.
Agreed. Alright, so for this problem we're going to be using a dynamics lens, and whenever we hear dynamics lens, we know that we cannot stop our hands from writing force equals mass times acceleration, because forces lead to acceleration. Alright, so really quickly, we'll run through the calculations. We have my acceleration is equal to the change in my velocity over the change in my time, which was 1.38 meters per second over 0.4 seconds equals 3.4 meters per second squared. For Raul, this was 1.28 meters per second over 0.43 seconds, and it gave us exactly 3 meters per second squared. So, even though we're the same weight and we would expect around the same force, there's a couple different frictional forces that kind of slow me down and make the force that he has to apply to slow me completely to rest a little bit smaller. So, quick calculation, 72.5 kilograms times 3.4 meters per second squared. We get about 246.5 newtons. That's what I apply to the wall, and the wall in turn applies to me. And for Raul, this is 72.5 kilograms times 3 meters per second gives us 217.5 newtons, which takes me to rest and accelerates him to his final velocity.